Hello everyone. I hope everybody is good today. And I think
Yes.
that most of you already joined. Okay, we can start. Let me share the screen with you. Okay, last time we kind of covered the replacement project analysis and we did some cases, like two examples were given. Now I would like to move to further to go with the chapter. So how the inflation affects the capital budgeting process. Analyzing the nominal and the real cash flow, the nominal cash flow, they reflect the impact of the inflation, while when it comes to the real cash flows, they're just adjusted to downward to remove the inflation effect. So the nominal cash flows should be discounted at nominal discount rate, and while real cash flow should be discounted at the real discount rate. So when you evaluate with the investment criteria, you should try to see what kind of rate you're using. Are you using the nominal or the real? So this is the information that is very crucial for us while doing some capital budgeting analysis. So changes in the inflation affect the project profitability. If we assume that the inflation is expected to be higher, the future project cash flow actually becomes worthless. We know that $100 today will be less worth $100 than after 5 or 10 years. Inflation reduces tax saving from the depreciation. So as we touch the aspect of the depreciation, why we are using different methods of the depreciation in order to save the taxes. However, the inflation it affects as well, affect negatively. So tax saving from depreciation is the cash flow, which is generated by deductibility of depreciation. And we know that depreciation is a non-cash item. So that is the product of the tax rate and the depreciation expense. So inflation decreases the value of the payments to bondholder. The bondholder are the creditors, like they're expecting to receive some money in the future. If, for example, you lend money in tenge and borrowed the money in dollars, you know how the creditors, they work, they borrow and they lend to somebody, they borrow at lower rate or they collect the money at lower rate and lend at higher rate. If they borrowed a dollar and lend it at the national currency and the currency depreciated, loses its value, in the future, the value of that payment that they're going to receive will be worthless, will be decreased. So inflation may affect the revenue and the cost differently. If the price of the good changes at different rate than the price of the inputs used to create those goods, so the firm's after-tax cash flow may be better or the worse than expected. So it depends on how they change. So project analysis and evaluation. What if we are choosing among the mutually exclusive project, but they have different life? Okay, we used to choose, let's say we are given like 3 projects. They have 5 years. And all of them have got the 5 years like A and B, C. But what about the project has got different life? So how are you going to choose in this case then? That will create a kind of dilemma for you to and it will not be right to select with the highest NPV, even though we have underlined that the NPV is the best investment criteria. We cannot say that it is valid in the case of selecting with the different lives of the project. If one project has got 5 years, the other one has got 6 years, so there's a problem in selecting it. So we'll discuss what is the capital rationing and how do we deal with this risk, okay? So when they're comparing projects, we have different useful lives and we cannot simply compare the NPVs because of the timing replacing the project. That would be the different. Hence, the number of the replacements between the projects would be the different in order to accomplish the same function. So we are given 2 approaches to solve this problem. The first one is the least common multiple of leaves approach. The other one is called equal annual annuity approach. So using these 2 approaches, that will help us to choose the best project, even though they have different types. So we are given here 2 projects, A and B. Sorry, G and H. with a required rate of return of 5%. So we are actually assumed to select here, if we didn't know this information, that we cannot select the project which has got the different life, different number of the years in the project duration, then we would definitely select with the higher NPV. However, we need to do something. We need to manipulate bits to get a real decision, the right decision. So we will start with the first approach, which is least common multiple of lives approach. So basically what you're doing here, you're replacing, you do the replacements, okay? How the replacement works in here, I will illustrate this in Excel, okay? I'm gonna illustrate it in Excel. I'm gonna illustrate in Excel. Am I recording or not? Let me just check it. Yes, I'm recording it. Okay. So I'm gonna illustrate this in Excel. Let me open the Excel. I have 2 projects and 4 years, and the other one is 3 years. So the idea is that we need to replace in that way so that they should be equal in terms of duration, okay? Project, let's say, project H and project J, okay? This is what we are given. Let me make it bigger, like this. And number of the years, like 0, 1, 2, 3, 4, 4 years. So let me just go with this. Project H has got 3 years cash flows, 38, 39, 40. Minus 100 investment dollar, and 38, 39, 40. 3 years of cash flows, okay? And project H, sorry, vice versa. Let me not to be mixed up. GH. Okay, that's great. And project G has got 4 years of future cash flows. 4 years of future cash flows. So calculating NPV is just simple here. We know the discount rate. The discount rate is given here 5%. Okay, it's 5%. It's very simple. So if you calculate the NPV, okay, NPV, you put the discount rate, you select the range, and subtract the investment cost. And of course, it gives you the percentages, but it's in dollars, okay? Let me dollarize it, everything. And same thing we do for project G, but in here, because the rate changed, okay, D1 from F3, and it should go a bit further here, 4 years, okay? Do we have the same answers? Yes, we have got the same answer. So definitely we could select project J. However, we need to do some replacement. We need to increase the number of years. So we need to kind of repeat the cash flows. This project lasts for 3 years, okay? Now we need to repeat this project, okay? We need to repeat this project. I'm gonna make it here. Okay, I'm gonna repeat this project. So how many times I can repeat so they will be equal to? They will be equal both in number of the years. So you have to repeat, I think, 12 times. You have to repeat 12 to the 12 years, until 12 year. Because this is 3 and this is 4. So the common number is 12. So I need to increase to the 12. Make it like this. Make it smaller so that it can fit. Now, I get this numbers, put it here. So I just copy this cash flows. Imagine my project finished in year 3. Now year 4 starts, I will start again the project with the cash flows. This started, it finished this, and my cash flow starts again. Here, again, and again. Now we repeated our cash flows 4 times. Okay, here, like, I mean, we repeated our project 4 times, like every 3 years. But in here, the cash flows are for 4 years. So that means that we will be able to repeat it only for
3 times.
For 3 times. Okay, now we equalize the number of the years. We equalized it. That's great. But the problem is that whenever you finish in here, okay, you finish here, the first project, it finishes in here, there should be cost as well, like the cost in here. And the cost is same, minus 100. So that means 40 minus 100. That will be minus 60. Okay? So 40, I put the equal sign, minus 100, minus 60. And it's same for again, like 1, 2, 3 here again. 40 minus 100. Here again, because end of the first project is the beginning of the new project. Okay, this is my project. And the same thing we should apply for the project G, like the same manner. Then now, what is your job? It is the first that you need to do is in this way, but next what you do is to evaluate, to estimate the NPV using the NPV function, like my NPV here. So NPV, my rate is 5%. My values are here for 12 years. Okay. And plus, I mean the subtraction of the investment cost. Okay, here we go. My NPV is this. So now you can see if you repeat, I mean, this is the NPV of the summation of all repeated projects. Like my summed NPV replaced NPVs is equal to $19 in this case, in project H. But let's see what's going to happen in project G. But in G, we should treat it as well. In G, it means that we have 4 cash flows. End of the 4th year, it is the beginning of the new project. So 1, 2, 3, 4. In here, our project ends and new project starts. So 30 minus 100. Okay. Let me make it with different color because it's a different project. So 1, 2, 3, 4. Same, like ending one project, starting new project. And we have what? That's it. That's it. 1, 2, 3 times. So second project, project G, was repeated twice. No, repeated in total 3 times. Now we can calculate the NPV. We change this one. And Yeah, all the number of years are included in here, the investment cost. Okay. Now we can see. Now you can select the project H. So project H should be selected because of the higher NPV. And now we can say that the project H is
Excuse
higher.
me,
Yes, please.
didn't we miss in project J 12 year?
No, we did not miss anything. Look, everything it was here missed the NPV, but in here we did it for 12 years. So they're same in numbers.
Oh, okay.
Okay. In here, the first time when we calculated the NPV, we just drag down, and you can see that it missed this year. But in here, as we equalize the number of the years, it automatically considered all the 12 years.
Oh, okay.
Okay, now we can select, but in here we select project G. However, if you make it with the least common multiple leaves approach, then you would select definitely project H. That is more profitable by 4 million. Okay. Let me save it. Do you want me to do one more example, but with different numbers?
Yes.
Yeah.
Yes.
Yes, please.
Okay, I will do one more time. But let me save it so that if something goes wrong, it's saved. It is, let's call it least common multiple. Least common multiple approach. Now, let me get the example from the book. Okay. I think this is what? Okay, this is the. Okay, here's the example. I will get this one. Okay. With a different rate, with different cost. But we didn't check whether our answer is correct because I don't remember I was doing here. Let me check it again. Okay. But let me just make it smaller. This. Put it here. Let's see it. Yeah, we're correct. H is 1991 and G is 15. Okay. You see, they do separately NPV here, but at the end, what they do, they just sum it up and they get NPV. So the best thing what you do here, when you get the NPV, you see 638, 638, it's not changing because you're using the same project. However, when you bring this 638 to here and this 638 to here, you will get 15. And when you bring this 6.12 to here, 6.12 to here, 6.12 to here, you'll get in total 19.91. So this is how they calculate in here. But I show you the best way, the easiest way to do it in this way. Okay? Don't be confused. So whatever way you find out is easy, you do it. So you can make it calculation NPV for each project that you repeat separately, then add them up. But you should add them at year 0. You should discount them to the year 0. Okay. Now, we are given two projects, which is projects S and L. Let me make it here. Project S and L. And minus 100, 60, 90. And we have minus 140, 80, 70, 60. So if you calculate the NPV for it, 0, 1, 2, 3 years. As you can see. Okay, you help me, guys. Just do the exactly same process. So we do just calculation of NPV function. But rate, we should see the rate. What is the rate? What is the rate?
It's 10.
10%. 10%. Select this range plus the investment cost. Okay. Okay, here's our MPVs. Here's our MPVs. Okay, but we cannot make any decision based on this. So we need to make some replacements of the project. So how many years we should make it so that they will be equal in the number of the years?
6.
6 years. Very good. Very good. I'm going to copy this. So I'm going to replace it by 6 years. Now, this will be replaced here. So in the first project, in the project S, the last year cash flow, it is the end of the project. At the same time, it is the beginning of the new project. So which is 90 minus 100. Okay. So 1, 2. Second time when I repeat it, the end of the project cash flow, it is the beginning of the new cash flow. It's the beginning of the new project. So sorry. So as you can see, we repeat it 3 times. And this one, we will be able to repeat it only once more. End of the cash flow in year 3 of the project L, it is the beginning of the new project. So we should make it minus 40. Is there any questions until here? Is there any question? You have it? If
No.
not, okay, that's great. Then we just calculate MPV. So MPVs here is equal to rate is 0.10. We select all the range plus investment cost, I mean subtraction. That's it. This is our MPV. Okay, any question? So this is, we call a least common multiple approach, multiple lives approach. And let me just recheck, double recheck so that we don't get, okay, 2835, okay. And 6 years as we did it, okay. 72, 60, that's great. Okay, that's great, that's great. Okay. Now we select project S. Okay. And let's see another approach. We said there are 2 approaches to measure if there are 2 projects with a different useful life. The first one was the least common multiple lives approach. The second one is called equivalent annual annuity. So in here, you're just computing the annuity payments. That will let you to kind of compare of investments, okay? So equal annual annuity. So we're having 2 projects. We're going to get the same project. We're going to get the same project. Let's get this one. Let's get this one. Okay. Project H and project G. So H has got the present value, this, the maturity, I mean the number of the years, the first project is 3 years, the other one is 4. Rate is same for all, 5%, 5%. And now our job is to calculate the annuity, the effect, the equivalent annual annuity. This is what we need to calculate in order to compare. The highest, the better. So what we do in here, we just calculate the payments. You can do this using the financial calculator. You can do this using the just Excel spreadsheet. So we open the bracket, we put the rate, number of periods, present value, and close the bracket. But here the payment is always coming as a negative number. So to get rid of that negativeness, we just put the negative sign before the payment, so that we can have absolute term, absolute annual payment. 2.25, okay. One more time. Payment, rate, number of periods, and present value. Let me repeat in here as well. Payment. I put the rate first. Present value. Sorry, number of periods, 4. And present value. You see, it directly comes as a negative. So in order not to have that negativeness, we just put negative sign here. Now, this is our conclusion. So let us just check it up, whether we are having the same numbers. Yes. So therefore, the project H is preferred. It has got higher the annual payment. Any questions?
Yes, I have one question. What's the meaning of the annual payment? So, what's the meaning?
It means that annual payment, how much you would get it annually, every year, with a discounted value.
Okay.
Okay.
Sorry, where we should put minus sign?
Why we need to put minus? Because in calculation in Excel, it directly calculates as it gives you a negative number. If you just remove it, you can see it's a negative, minus 2.25. But it's just Excel function like this, okay? That's why we just remove that Excel function negativeness. We just put this minus sign.
Okay, thank you.
Okay. Let us move. So decision making under the capital rationing. So when there is a capital rationing, the company may not be able to invest in all profitable projects. And even though they have enough capital budget and enough, what do you call it, all the NPVs are positive. So the key to decision making under capital rationing is to select those projects that maximize the total net present value for a given limit on the capital budget. So we're given project here, okay? Project 1, 2, and so on. We can see that NPVs are here. NPVs are here. Consider the following project with a required rate of return 4%. Which project would you select as a capital? One, 2, 3, or 4, and 5. Actually, you would select any of them, but you would select definitely the first one. You would select the first one. you would select the project which is giving you the highest NPV if you have a budget of 500. And possible decisions that may come up as an optimal choices that maximize the total net present value could be this, like 1, if 1 and 3, 1 and 2, and 1, 5. These are the budgets that are given. If your budget is 100, if your budget is 100, okay, if your budget is 100, then you would select only project number 1, which is this. If your budget is 200, you would select still 1, because why? If your budget is 200, you would still select 1, because the NPV is here is given to you, your budget doesn't allow to go further. So you do take your decision based on your budget, and you try to select the best investment. If your budget is 500, you would select 1 and 3, because the NPV in 1 is 20. Look at here. Project 5, you have got budget 500, 500, okay? You would select 1 and 3, 1 and 3, because it gives you total NPV as 60. However, you can select this one directly with the budget of 500. However, it gives you just 45. You see? So you are selecting the highest NPV, that's the accumulation NPV. Okay, this is the logic that you are following. So if you're given, let's say, budget as 400, then you should select the summation. So according to this, you can select this, okay? Project 3, you are able to select this, but you cannot select project 5. Sorry, project 4, you cannot select because your budget doesn't allow it. But you can select project 2 and 1. So if your budget is 400, which project would you select?
1 and 2 because NPV is 50.
1, 2.
1 and 2 because the NPV gives you highest NPV in accumulation. Selecting this and this, nothing, doesn't work. So you select with the highest NPV. So capital rationing is divided into two, like hard capital rationing and soft capital rationing. So hard capital rationing occurs when the funds are allocated to managers under the capital budget that cannot be increased. This is called hard capital rationing. Soft capital rationing occurs when the managers are allowed to increase their allocated capital budget if they can justify or convince the senior management that the additional funds will create the shareholders' value. Okay. Okay, here I want to stop and I want to give you to do some practice question now. So I don't want to move to this risk analysis. It's another subject this we're gonna cover next week, but I want you to practice one question. It's a very good question. Everybody has got the access, yes, to the book. Okay.
Book or presentation? Ah,
Book,
yes.
book, not the slides, the book.
Yes.
Okay, there is a example which is called 2.7 capital budgeting with a spreadsheet. Page 100. Page 100. Please now try this example using the Excel. Okay, they got the answers in here, but I want you with functions. How they got these numbers? How they got these numbers? I want to try it, okay? But in a spreadsheet to calculate the NPV and IRR. Now try it, please. Go to the book, open this example, 2.7, and try it. I'm here. If you have any questions, please feel free to ask it. The very tricky part is this part. But the others, you already did it and you know how to do it. Try it now, because we have still time, like 15, half an hour. So half an hour is more than enough to finish it. And while you're doing it, I will create a link in Moodle where you will submit it, okay? I will accept it as activity. So do it now. I'm creating the link for this example where you're going to submit your Excel spreadsheet. So 30 minutes, it's more than enough to finish it. But if you're stuck in this, I can help you. Just let me know. I'm here, okay? Just let me know if you have any questions. So read the questions and do it. I'm stopping the sharing and I will go to Moodle now.